when I look at A, when I look at this A right here, what number makes the denominator equal to 0? So, we need denominator equal to 0. So when I look at this guy, I set x minus 2 equal to 0. So then this means that x is equal to 2, right? So if you take the limit as x approaches 2 from the positive side, 1 over x minus 2, we know it's going to be some sort of infinity because the numerator here is non-zero and the denominator here is going to be 0. The question is it going to be positive infinity or is it going to be negative infinity? So I want you to think about it for 2 seconds. Type your answer in the chat box. Is it positive or negative? And then I'll count it down. If you don't know, just say you don't know. Ready? So the 3 choices are positive, negative, don't know. Type your answer. I'll count it down. 3, 2, 1, go. A lot of don't knows and some positive. No worries. So what number am I plugging in here? I'm plugging in some number like 2.01, for example, right? And then when you look at the sign of the numerator is going to be positive because the numerator is just 1. The denominator is going to be 2.01 minus 2. Is that a positive number or a negative number? That's going to be positive, right? So we basically got positive over positive. Positive over positive, that means we're going to get positive infinity. So that's the correct answer, positive infinity. Okay. So let's take a look. Let's come from the other side. Let's say we did the limit as x approaches 2 from the negative side, 1 over x minus 2. Which one do you think it's going to be, positive infinity or negative infinity? I was going to do 3, 2, 1, go again, but Luis already says it's negative. Luis, can you tell me what number you're plugging in? Plug in something like 1.999. So you have a positive number over 1.999 minus 2. That's going to give you a negative number, right? So a positive number divided by a negative number, that's going to give you negative infinity. Does that make sense to everybody? Is there questions about this?
Is that line next to the F, like toward the bottom, does that signify that it's negative?
The line next to the F. Oh, yes. That's what I was trying to do. This guy right here, right?
No, all the way on like where the function starts, like the actual function, like the printed version.
This?
Yeah.
No, that's a typo or
Oh,
a glitch in the matrix or something.
Okay.
Sorry if that threw you off. Maybe put a little tail like that. All right. Does anyone have any questions about this example? Okay, let's take a look at example B. When you look at this expression G over here, what do you notice about the numerator? Does anyone notice anything about the numerator? Oh, wait, we got to back up. Aram has a question. He says, how do we know the limit approaches 2 here? So Aram, the first thing I did, you're going to have infinite limits when the denominator is equal to 0. So the very first thing what I did was I took the denominator and I set it equal to 0. And I solved. And when I solved this, I got x equal to 2. That's why I knew to look at 2. Yeah. So because the denominator here is also equal to 2, I would look at 2 again. Does that make sense? All right. So look at G here. What do you notice about the numerator? This is something nice. Does anyone? Exponent is higher. Okay, I agree. I'm looking for a 3-word phrase. The middle word is of. The first word begins with a D, and the last word begins with a S. This is a. Never mind. I'll just tell you.
A difference of squares.
That's right. Difference of squares, or difference of 2 squares, I should say. So I'm kind of taking the opportunity to review some algebra with you guys. So if you have a difference of 2 squares, I guess I forgot the word 2. 2 squares. This is going to be a squared minus b squared. That's equal to a plus b times a minus b. This is a factoring formula that we use a lot. Okay. So when I look at this g of x, you could think of this as a difference of 2 squares. So when I factor the numerator, that's going to be x plus 2 times x minus 2 divided by x minus 2. Make sense? So check it out. I can cancel this term in the numerator with this term in the denominator because it's the same term. Okay. And we can cancel because the numerator is a product. So if the numerator is not a product, you can't cancel. So I have students that try crazy stuff like this. They'll say like x plus 11 divided by x. And then they'll try to cancel the x's like this. And that's totally illegal. You can't cancel that because the numerator is not a product, it's a sum. So you can only cancel if it's a product like we have over here. So this is an eyesore, I have to erase it. Just wanted to throw that out there because I see that mistake a lot. Okay. So after we do this, we're going to get, when we simplify, we're going to get this, x plus 2. But I need to put one extra condition if I want to put an equal sign right here. The extra condition I need to put is I need to say x is not allowed to be 2. And why is x not allowed to be 2? Because in this particular function, 2 is not inside the domain, right? You can't have a 0 in the denominator. So I capture that by putting this extra little condition right there. So do you guys know what the graph of g of x looks like? The graph of g of x looks something like this. We're going to draw a set of axes over here. And here's 1, 2, and here's 1, 2. And I'm actually going to put, sorry, I need 2 more points, sorry. 3, 4, like this. And when I go to graph this guy, I actually have to put an open circle here and then draw a line like this and a line like this. So if you were wondering in the past, how do we write these equations of lines when they have a hole in there? Well, what ends up happening is the original expression looks like this, and the hole occurs because you canceled out a 0 factor from the denominator. So this line is given by this equation, and you can write it like this as long as you make sure you put a hole at 2. Does that make sense to everybody? Is there any questions? So I have a question for you. Do we have a vertical out? Do we have a infinite limit here or not? I would say this has no infinite limit. Right? Because when you plug in a 2 in the top and the bottom, you get 0 over 0. You don't get a number not equal to 0 over 0. So this example kind of illustrates the difference between the two. This one has an infinite limit. This one does not have an infinite limit.
I have a question.
Yes, what's your question?
Why is there a open dot, but the line still continues?
The line still continues because this line is basically y equal to x plus 2. Right? I said this is equal to x plus 2, so it's y equal to x plus 2. The reason why it has an open dot at 2 is I'm not allowed to have x equal to 2 because that would put a 0 in the denominator. And you can't have zeros in the denominator.
Okay.
But this guy right here, that's the equation of a line. So that's why it's like a long line, just a hole there because you can't have a 0 in the denominator. All right. What's the difference between G and H? You look at this guy, you look at this guy. What's the difference? They're just reciprocals of each other, right? C is just, where the function G is just the reciprocal of the function H and vice versa. So I could have come over here. I could have said, oh, this is x minus 2 over x plus 2, x minus 2 like this. And then these guys kind of cancel each other out. So I end up with 1 over x plus 2. So I should probably mention that x is not allowed to be equal to 2 here because you can't have a 0 in the denominator from this guy. Okay. So when you look at this graph, where does this graph have a infinite limit? Does anybody know? That's right, Luis, x equal to -2. So we have a infinite limit at x equal to 2. Okay. Why is there a 1 on top right here? So what happened was this guy is equal to this. I factored the denominator. And then because I have a common factor of x minus 2 in the numerator and x minus 2 in the denominator, I was able to cancel both of those out. And that leaves a 1 on top. And just the x plus 2 survives on the bottom.
For this one, how come the infinite limit is at 2, but for the previous question, it's no limit or no infinite limit?
Actually, I made a mistake. I wrote 2, but I meant to write -2. Because I don't know if you saw Luis wrote -2 there. I just wrote the wrong number. So
Okay.
does it make sense that it's -2?
Oh, because -2 plus 2 is 0, and then a number over 0 is a infinite limit.
That's right. That's right. So that's my bad for writing the wrong number. I'm glad you fixed it for me. And what you said is exactly correct. Okay. Just out of curiosity, do you guys know how to graph this guy? Can anyone describe this graph to me using transformations? No feeling. So if you have y is equal to 1 over x, that's the basic graph. That looks something like this. That was an example we just did, right? So if I have y is equal to 1 over x plus 2 versus y is equal to 1 over x plus 2 like this, what's the difference between these two graphs? This one versus this one. No feeling? Which one? The right one or the left one is moved up by 2? That's correct. This is up 2. What about this one?
That one moves left too.
This is left 2. So our graph looks something like this. Does that make sense? This is left 2. So if I were to take this picture, copy it, this is the picture that we got basically. The only thing is we need to fix it a little bit because you see how we have x is not allowed to be 2 right here. So what I need to do is I need to come over here. I need to take my eraser, or let's just say here's 1 and here's 2. I need to take my eraser and I need to put a hole. Whoa. I need to put a hole there. Put an open circle at 2. So this is what my graph looks like. First, I have this rational function. I factor the denominator. I can simplify that. I end up with a different rational function. This is just my basic graph of 1 over x shifted to the left by 2. So it looks like this. And because I can't have x equal to 2, because I don't want a 0 in the denominator, I have to put an open hole there. Okay. But this is an infinite limit. At x equal to, well, I already wrote it. At x equal to -2. We write the same thing, sorry. All right.
Could you go back to where you were drawing the graph for 1 over x? Oh, yeah. Thanks.
I will definitely post both of these to Canvas after class. Do you know, did I show you guys where to find the class notes? Does anyone need to see that? It's in the files section. There's a folder called completed notes. I usually post all my work there for you to figure out what's going on after. Okay. All right. So let's take a look at this last one. Where do you think you might have a vertical, infinite limit?
0.
0. It's an infinite limit. Right, because if you plug in a 0, you're going to get -2 over 0. So this top part is not equal to 0. So you got some number not equal to 0 divided by 0. So then you have an infinite limit. Okay. So let's check. Let's say I took the limit as x approaches 0 from the negative side, x minus 2 over x. Do you think this is going to be positive infinity or negative infinity? Let's take a second. We'll do the 3, 2, 1 thing again. I want you to look at this guy. I want you to think, oh, do I think it's going to go positive infinity or negative infinity? I want you to type your answer in the chat box. We're going to count it down. 3, 2, 1, go. 1 vote for positive, 2 votes for positive. Okay. Okay. All right. You guys are not easily fooled at all. You all say positive. I agree. What would a good little test point be? Maybe a good test point would be like negative 0.001 divided by negative 0.001 minus 2, right? And all I care about is the sign. I know it's going to some sort of infinity. So the numerator is going to be negative. The denominator is also negative. Negative divided by a negative is a positive number. So you are correct. It is going to be positive infinity. Is there any questions about these examples?
So basically, for example, 6, we're trying to make the denominator become 0. So we can make it into infinity.
For which one?
For this, all of we're trying example 6.
Yes, we're making the denominator equal to 0, the bottom.
Okay. Thank you.
You're welcome.
Can I ask about part C?
Yes.
So you know how like part A and part D, like we had like positive infinity or negative infinity.
Right.
For C, would it be a positive or negative infinity?
It depends which direction you come from. So
Oh, okay.
I did only the negative here. If I do the positive, you know, like let me continue, I guess. So if I do, I don't know why I write it like this all over the place. Let me move this over here like this. So if you look at this guy, if we took the limit as x goes to 0 from the positive side, which one would it go to? Well, in this case, you would have x minus 2 over x, right? The top is still going to be negative because 0 minus 2 is still negative, but the bottom is going to be positive because you're plugging in numbers like 0.001, for example. So a negative divided by a positive would give you negative infinity. So I'm sorry. Yes, negative infinity. So you come from one direction, you got positive infinity. You came from the other direction, you got negative infinity. I just didn't do, oh man. I just didn't do the one-sided limits for this example. But if you did it, you could use this picture to see, you know, this is going to negative infinity coming from the left. This is going to positive infinity coming from the right.
Oh, I see. Thank you.
No problem. I think I was a little inconsistent. Like the first one, I did 2 one-sided limits. And then the second one, I talked about the graph. And then the third one, I talked about the graph. And then the fourth one, I switched back to talking about one-sided limits. We just kind of use this as a vehicle to talk about the different algebra stuff I wanted to discuss with you.
Professor?
Yep.
For the D, when we try limit x coming to positive 0, yeah, if we try the number of 5,
5 is not close to 0.
5
is really far from 0. So that's a great question. Like you need to plug numbers that are very close to where you're going, not kind of close, you know?
Like how close?
Very close. because a limit means you're getting as close as possible. So I just look at a sequence of numbers that's getting as close and close as possible, but like infinitesimally close. Like if I was going to 2, I'd go 1.99999, for example. But really, a lot of times we're just looking for the sign, like is it positive or negative? Because you already know it's going to be like 0.
So it makes sense now.
Yeah.
Because before I tried with number 5 and it's the
Yeah,
answer is positive. So
right. I
Yeah.
mean, 5 is not very close to 0 or 2. So yeah,
thank you.
no problem.